session. Please confirm that all of you are able to hear my voice very clearly.
Yeah.
Okay. All right. So now today, what we are going to discuss, the first thing is that we are going to discuss at the algebra of derivative of functions. Okay. In the last class, what we discussed about the fundamentals of differential calculus as a rate measurement, then the fundamental formulas. But today, what we are going to discuss is discuss about the algebra of derivative of functions. So, um, just let me pull the first slide here, and then we'll discuss. I think it is clearly visible to all of you.
Yes.
Okay. So what it says is that that differentiation of a constant. So ddx of c, what you see here, no, that is equal to 0. Okay. So let's understand this point little more. If you see what is ddx, ddx stands for it is a rate of change of something with respect to x. Na?
Yeah.
The moment I say it is ddx, then your question should be, sir, ddx of what? If I say ddx of y, that means is that rate of change of y with respect to x, isn't it?
Yes.
So then, if I say ddx of c, what does it mean? It is the rate of change of c with respect to x.
Yeah.
But think about a constant. Constant never changes, right? So rate of change of constant with respect to x or with respect to anything is always 0 because there is no change.
Changes.
Correct or not?
Yes.
That is our common understanding, and how it actually our common understanding is actually we abide by the formula that also I showed you. Second one is that, dear students, if you look into it, ddx of c into u. By the way, what is u? U and v, we are assuming the two functions of x. Two functions of x. We can assume two functions. Let's take u is equal to x square, and v is equal to suppose 3x. No problem. We can take, and we'll see all these formulas by means of this. So ddx of c into u, that is equal to c into du dx. Correct or not? Why? That constant we can take always outside of the differentiation. Okay, got it?
Yeah.
So ddx of c into u, for example, in this case, if I give an example, ddx of what is u here? X square, na? In context to our discussion, suppose I gave 5 into x square. That you can clearly write, you can take 5 out and ddx of x square.
X square, yeah.
Did you get my point? What I'm talking about?
Yes, I got.
So, in context to the first one, I can say that ddx of a constant, suppose 5, is always equal to 0. It is not with respect to x, with respect to anything.
Yes.
Correct or not?
Yes.
Third one is that ddx of u plus v is equal to du dx plus dv dx. Correct? So let's take an example. So just a minute.
Yeah.
If I take an example of here, is that, let me do it little short here. Okay. So I say the ddx of u plus v, what is u here? X square, no?
5 plus 3x.
And vx is what? 3x?
Yeah.
So that is equal to ddx of x square plus
ddx of 3x.
ddx of 3x. Now, ddx of x square, who can say what is that one?
2x.
Fantastic, because we understood yesterday that ddx of x power n is equal to n into x power n minus 1. You can open your previous day's class note and have a quick look into it. Plus, we just learned that ddx of 3x, 3 is a constant, so we can take it out. 3 into ddx of x. 3 into ddx of x is what? 1.
Yeah.
ddx of x is 1, right?
Yeah.
So it is 2x plus 3. Clear or not clear?
Yes. Got it.
Okay. Similarly, you can find ddx of u minus v is equal to, so this one, okay, you
Okay.
can take here. This thing is that ddx of x square minus 3x in the same logic, that
Hmm.
is equal to ddx of x square minus
Minus.
ddx of 3x, correct or not?
Yeah. Yeah.
So that is equal to ddx of x square we just discussed, it is 2x and it is 2x minus 3.
Yeah.
Now, the next point what we are going to discuss, these two next two formulas are a little important one. So
Okay.
first one is that ddx of u into v. ddx of u into v is equal to first u into dv dx
Oh,
plus v into du dx. Let's take an example to understand. Correct? So
yeah.
suppose I write ddx of u into v. What is u? X square
Square.
into 3x.
Hmm.
Okay,
Okay.
correct or not?
Yeah.
So if we apply the formula, what we are going to get? It is u into dv dx. That means x square into ddx of 3x. Correct or not?
Yeah. Yeah.
Plus dx into ddx of x square.
Yes.
I hope all of you agree to me.
Yeah.
Anyone has the simplest doubt, please do ask me. So now we just learned x square into ddx of 3x is 3.
3.
Correct or not?
Yeah.
Plus 3x into ddx of x square is nothing but 2x.
2x. Yeah.
So that is equal to 3x square plus 6x
6.
square. So that is equal to 9x square.
Okay.
But we can do it in some different manner also. The moment you see, sir, ddx of x square into 3x, I can look into in different manner, na, sir. You can say like this thing, that is equal to ddx of x square into 3x. That means 3 into x cube, right?
Yeah. Yeah.
Then we can take 3 out because it is a constant. 3 into ddx of x cube. What is the formula of ddx of x cube? If we apply the formula, what is the value we are getting to get?
Square into 3.
3 into x square.
Yeah.
Correct, na?
Yeah. Yeah.
That is equal to 9x square. And the same result we are getting, na?
Hmm. Yes. Okay.
I hope
Okay.
all of you got it.
Yeah.
And the next formula is also very quite important. And the next formula is ddx of u by v. Okay. What is ddx of u by v? That is equal to first what is there in the v that you can take in the denominator. That is v square. Correct?
Okay.
Clear? That is
Yeah.
v square into then in the numerator we will take v into du dx minus u into dv dx. Okay. Let's take an example so that it will be much more clear. Okay. So we are do it here ddx of u by v. What is u here? X square
By 3x.
divided by 3x. Let's do it by applying the formula. Okay.
Okay.
So now if we apply the formula, then what we are going to get it? So that is equal to v square. Correct or not? That
X
is
square.
3 into x whole square.
Yeah.
Then v, that is 3 into x. Correct or not?
Yeah.
Into ddx of u. U is what? X square.
Yeah.
Minus u, that is x square.
Yeah.
Into ddx of 3x. Correct or not?
Yeah. Yeah. Correct.
I hope all of you are able to get my point, dear
Yeah.
students. So that is equal to what? That is equal to, we are going to get 3x into x square, 3x.
3x into
Then x square is what? 2x,
2x.
if you
2.
recall.
Yes.
minus x square into ddx of 3x is 3
3.
divided by 3x
9.
square means what?
9.
9x square. Now 3 into 2, 6x square minus 3x square.
3x.
3x square divided by 9x square. So that we are going to get is at 1 by 3.
Yeah.
Correct or not?
Yes.
1 by 3.
Okay.
Since x square is not equal to 0.
Yeah.
Correct or not?
Yeah. Yes.
But you know, dear students, we can take it in a very easy approach also. We apply the formula. Same manner, we can write this is equal to ddx of x square by 3x. That is equal to x by 3, no?
Yeah. Yeah.
Since x is not equal to 0. So that's why we are able to divide. Correct or
Yeah.
not?
Yeah.
So now 1 by 3 is a constant. 1 by 3 into ddx of x.
Oh, so it's 1 by 3.
1 by 3. So you see both the results are matching.
Yeah. Yeah.
Sir, why you take this big effort to do this thing? Because we need to know the formula also. Here we
Hmm.
took the function, one is x square, one is 3x. Think about if I take two different functions. Suppose u is equal to x square and v is equal to log of, sine x. Then you need to apply the formula properly, right? U by v, correct or not?
Yes. Yes. Yes.
If anyone is having any question, please feel free to ask me, dear students. Okay.
So dvdx means ddx, like,
D- okay, sorry. Please tell me once more which line you are talking about.
so like in the formula it's like v into dvdx, right?
Yes, v into u into dv dx plus v into du dx.
So that like dvdx means like d,
ddx
like,
of v. ddx of v. V is a function of x.
okay, 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 okay. That's
dv,
v
huh,
into dvdx, right?
yes, yes,
That's
absolutely.
what,
So for example, your question is that, sir, what is mean by dv dx? Correct,
yeah,
no?
that's what I'm saying. Yeah.
So what is mean by dy dx? That means ddx of y. So what is the meaning of dv dx? Is ddx of v.
X of v. Okay.
So what is ddx of v? What is v? V is equal to, in this
Yes.
context to the question is 3x.
Okay. Okay.
Correct or not?
Yeah, got it.
dy dx, if you look into yesterday's class and if you follow
So
the
that
yesterday's note, dy dx means what? ddx of y.
x
Now
of
what
y.
is y? Y is a function of x. We discussed about function little bit yesterday.
And, okay, I understood. Yes.
Correct or not?
Yes, I understood.
Okay. Then the next formula, that is equal to, that is ddx of u power v. ddx of u power v. Okay. So as you see here, ddx of u power v is, uh, it is u power v into u v by u into du dx plus ln u into dv dx. Correct? So let me show you how it has been used. Okay.
Sir, what is ln?
Ln is log to the base e.
Okay.
Okay. If you flip into your class note, then you'll get it. So what I wanted to mean by that is equal to ddx of ddx of, it is u is what? U is equal
X,
to x
X,
square, no?
yeah,
X square power 3x.
3x.
That is the formula we are going to use, no?
Yes, yes,
So that is that is what we are going to compute, correct or not?
yes, yes.
So that actually says that this is equal to u power v. That means x square
X
power 3x,
3x.
correct or not?
Yeah,
Then
yeah.
u by v, sorry, then v by u. What is v? V is equal to 3x
3x by x square
by x square, correct?
by x square.
Into ddx of u, du dx, that is ddx of u. What is
Yeah.
u?
X
U is
square.
equal to x square
Okay.
plus ln of u. What is u?
is
U is
x
equal to x square
square
into dv dx.
dv
dv
dx.
dx
Yeah.
means ddx of 3x, right or not?
dx of 3x. Yeah. Okay.
Dear Divanshu, you asked about ln. Ln is nothing but log with a base e. If you recall that log, we can say log of b to the base a. Now we can change the base. If the base is e, then it is called log base e, which is also known as ln. Sometimes we say the base is 2, okay, that actually being used in computer science. So because of the binary number system, so we say log base 2, that means lg. Or sometimes we take the base as 10, which is in the decimal number system, that is called log base 10, that is actually generally denoted by log. Got it?
Okay.
Yeah.
Okay.
E is that very small number, right?
Yes, it's this number, not
Okay.
very small number. It is that is epsilon.
Oh,
It,
okay.
it is not a. It is not a. It is. It is not epsilon. E is a number. Got it?
Why is it known as E then?
Okay, very good question. Okay, the point is that it is known as the Euler's number. E is known as the Euler's number. Okay, so its value is actual value is 2.71827. Okay,
Okay.
so is the first letters of the inventor's last name. Okay, Leonhard Eulers. So he invented that one. So it is known as a mathematical constant. Okay, you got my
Yes,
point.
sir.
Okay, so now um, the way we find the approximate number of pi, correct? Similarly, we can find the approximate number of e. Did you get my point? Okay, and the
Yeah.
number is approximately we take that number is equal to, as I said, that is 2.71. Okay, you got my point. What I'm talking about,
Yes, sir.
correct or not? Okay, so that is about the fundamental formula. Now, what we are going to discuss is that few rules of further few rules of in differentiation, and followed by we'll start solving some problem. Okay, first one, derivative of function of function. That is a very very important topic. Okay, I want to start with a example. Derivative of function of function. Okay, so let me first tell you what is meant by that, and then we'll start an example. That is a very important part of that discussion. So that is okay. I hope all of you are able to view the screen properly.
Yes.
Please confirm that you are able to view the screen properly.
Yes.
Okay.
Yeah.
Now, so let's now discuss on this thing. So what is that? Y is equal to fu, be a function of u, and again u is a function of x. Y is a function of u, and u is a function of x. So that is, we assume that u is equal to gx.
Okay.
Correct? No?
Yeah.
U is equal to gx. Point is that how we can find of this dy dx. Okay. For that, the formula is that dy dx. First, you need to make is that dy du, because y is a function of u, na?
Yeah. Yeah.
Function of u. That's why first we find dy du,
Mhm.
and then du dx. That is, u is a function of x. Correct? So that is actually also known as a chain rule. Let me show you by means of an example that will be very clear to you. Correct or not?
Yeah.
So, for example, let's take y is equal to 2x plus 3 power 5. Okay. So, what we are saying is that, what we are taking is that, suppose y is equal to, y is equal to 2x. Just a minute. There is a little delay in. Okay, dear students, let me do one thing. It looks like there is a delay in while I'm writing. So let's see. I'll continue for a minute. If it is too late, it is too delayed, then I will cancel that call and I'll call you back again. Okay.
Yes.
So what I'm saying is that 2x plus 3, power 5. You able to view this one, dear
Yes.
students?
Yeah.
Able to view it, no?
Yes.
So let's discuss this thing, that 2x plus 3 power 5.
Mhm.
What about the formulas you have learned so far? If I ask you, find the differentiation of 2x plus 3 power 5, you really cannot find that formula there.
Yeah.
Correct? If you find the formula, let me know which formula it is. You will not able to find a formula which will help you to, differentiate 2x plus 3 power 5
Yeah.
with respect to x.
Yeah.
And what to do? There is a way out. Is that we can assume that 2x plus 3 is equal to, some other function, that is u. What I'm saying is that we can write that y is equal to, just a minute, y is equal to u power 5. Okay, let me do one thing. It looks like there is a delay. I will call you back in another 5 minutes. Okay.
Okay. Yes. Sure.
Okay, fine. I'll send you a different link, and you need to click into that one, and we will resume our classes. Okay. Thank you.
Saraki chapter.